Hello, welcome to my presentation about running MariaDB server on Kubernetes. We will discover how to run MariaDB in Kubernetes using the MariaDB operator. So let's start with some presentation about who am I. So my name is Frederic Descamps. I am known as Le Fred on multiple social media. And I am MariaDB community advocate working for the MariaDB Foundation since 2026, since February, so quite recently. I am a long-time user of MariaDB and MySQL, and I started with MySQL with the version 3.20, so a long time ago. I'm a DevOps believer, and I'm living in Belgium. I also have a website called lefred.be, which is my blog, where you can find a lot of information related to MariaDB. Before we start talking about Kubernetes, let's give some words about the MariaDB Foundation. So what is the MariaDB Foundation? The MariaDB Foundation, it's a non-profit organization, and we have three big missions. So our mission can be divided in three big goals: the adoption, the openness, and the continuity. Adoption meaning that we want to grow the users of the MariaDB server, and we keep educating people with webinars, blog posts, and so on, presentation. Openness, so we need to be sure that the development is completely transparent, that the governance is transparent, truly open source, and we also handle the contribution from external people, and the continuity. We want to have a long-term stability, and of course that it stays open source, and so on. So here we have a list of our main activity, and MariaDB PLC and MariaDB Foundation are two different entities. Of course, we work together also. So the PLC, it's the commercial entity that does the product and develop the product and the commercial product. And also they decide on the roadmap, but not alone. We also say something to work to them, but that's them to manage that, and they are responsible of it. The MariaDB Foundation, in the other hand, is the open source governance that we pay a lot of attention to, and the community development, meaning that we also check all the external contribution to the code, and we try to grow the ecosystem. So if you want to be part of our sponsors, because companies are sponsoring the MariaDB Foundation, you are more than welcome. And this is a list of our sponsors, and we have recently added new sponsors that are not yet on the list. But please go on mariadb.org to find more information and to see all our sponsors. I also invite you to visit the new MariaDB server ecosystem hub. That let's say it's a hub with plenty of different categories and plenty of different product or service or solutions, I would say, that are part of the Eco Hub, such as plugins, but also monitoring, storage engine, and so on. So if your product is not there and you think it should belong to it, just visit, and you can submit your solution there too. So now let's go back to Kubernetes and discuss about the running MariaDB server on Kubernetes. So Kubernetes, it's an excellent solution to keep containers running, right? So when you have an application, this is cool, it runs, and if there is an issue, restart the application, we need more application, it will deploy more application, and so on. This is easy. Database, it's a bit different because a database needs more. Database need a stable identity. You cannot connect anywhere on any of the database. You need to know where you need to go also. The database needs to have a durable storage. It's not that, oh, we just restart it or redeploy the pod somewhere, and all the data that was there is cancelled, disappeared in dev null because yeah, we didn't use durable storage. So this is very important. Startup and the shutdown order, it's also very important. You want to first start a primary and then replicas, for example, or during upgrades and stuff like that. So this is very important to know what to do when and how. Backups, restore, we need to deal with that, and we will discuss that later in the presentation. And also upgrades, failover, and something that it's also very interesting. It's the day two operation, how to make them safe, but I will discuss that later on that too. So what is an operator, in fact? So an operator in Kubernetes is just a piece of software that will automate all these complex tasks. And for example, if you're a DBA and you need to tune databases and stuff, you will have what we call runbooks, step-by-step guides for managing the database. And you need to have this to run all this inside of Kubernetes with the reconciliation process, meaning taking all these manual steps and manual instruction and execute them continuously and automatically inside Kubernetes. So in practical terms, it means that the software doesn't just deploy the database. This is the easiest part, I would say, but it will always, it needs to always check, so constantly checks if the database is healthy, if the database is taking the backups, it's scaling if needed, if it has some issue, fix them, like a human admin would do, but all by following some code instead of manual document. So this would like about like, okay, when we use an operator, we go from manual instruction to automation instruction, and we will have this reconciliation loop. This is a very important terms in Kubernetes when we use an operator. So the operator will constantly compares the desired state, like, oh, we need 3 healthy nodes, database nodes, with the current state. For example, oh, there are only 2 nodes running that are responsive. So what action should I take to go to the situation that we really want? It's 3 healthy nodes, not only 2, right? So this is what the operator does. And finally, the operator helps also on this day 2 operation, meaning the operator will handle the maintenance, like taking the scheduled backups, rotating security certificates, applying software patches and stuff like that, normally without human intervention. This is the goal, right? So let's have the agenda of the presentation, now that I've already talked a lot. In the agenda, we're going to see what are the Kubernetes primitives that MariaDB depends on. And then we will see what what will be the addition of the MariaDB operator in Kubernetes. We will see how to install the operator. We're going to create our first instance with YAML files. Then we will see some resources there, the common, the extra resource definition. So with the custom resource definition, so that are the database, the user, the privilege, and so on. We will see how to handle the backups, the restore, and some words about HA. And finally, I will give you some practical tips for production. So the first principle, it's not about how do I run a container. So we should not start about how do I run a container. So how do I run MariaDB inside of a container? But the right start would be, how do I operate the database in Kubernetes? And so this is what is more important for us. So, and the database operation, that will include the provisioning, the configuration, how to access the backup life cycle, testing the restore, doing failover, and the observability and upgrades. So all that, it's part of how to operate the database. And we need to answer all of these questions to be sure that we deploy MariaDB correctly in Kubernetes. If you don't know what database provisioning is just a process that will set up the database and make it ready for the application to use it, meaning installing the software, adding the schema, creating the users, and all that kind of stuff for the application to use it. When we are in Kubernetes, there are some Kubernetes objects that we're going to meet, and that we also need to know about a bit. It's like, for example, I will talk about pod. Pod is what runs the database server in the container. Then we have also the service, so the endpoint of where we need to connect using the network to use the service. Then we have the secrets. Secrets are the credentials to access something. Then we have the config map. Config map is the configuration of the server. Then we have persistent volume claim. So we will request for some storage, and it should work. We should get it to have to use that storage. Something that we will come back very quickly is the stateful set. So this is what gave us the stable identity plus the ordered life cycle. Then we have custom resource definition, so the CRDS. We will talk about that. So these are the new Kubernetes API types. And finally, the controller, the operator, that we do this reconciliation loop to see what the status we want and what we have. So why stateful set matters? So the stateful set will give us already a lot, right? Like, for example, it will provide us predictable pod names and DNS names. So now when we deploy database, it's not like we want to have a random database and then connect to it randomly. We don't really know. So it needs to be, okay, we want to deploy MariaDB DB1 or MariaDB production server, blah, blah. So we need to know which database and what would be the name of it and so on to be able to connect to that specific one. Then we need to have a stable and persistent storage for per pod. So when we create our instance, the data that will be there need to be safe, secure, and not lose it if we do something, an operation like stopping or whatever. And after that, we also need to have the graceful deployment in order, like we said earlier, and rolling upgrades. So this is a major block for databases, right? To have the possibility to do all these steps in order, but this is not a DBA yet, because stateful sets are really essential for application where each instance needs to remember who it is and where its data is, where. So that's very important. So if we compare a deployment versus a stateful set, we will see, for example, that the storage on a deployment, it's shared or ephemeral. On a stateful set, it's dedicated per pod, right? So, for example, the identity can be interchangeable. They are identical. In stateful set, they are unique and sticky, right? So this is a map representing the stateful set and MariaDB. And so we can see that the stateful set will manage ordered stable MariaDB pods, and we can see the pods there that have all their own persistent storage and so on, right? So what we don't have here yet, it's the backup, the restore, the user management, grant management, and databases operation. So the stateful set is really necessary, but it's not sufficient. So what it gives us, so it will give us this identity, that is sticky identity that we need, but it also give us the storage binding, so excellent, the ordered life cycle, we were looking for that, and the restart behavior. However, we still need backup policies. We still need restore workflow. We still need user and grants. You still need topology awareness. So what type of replication are we using? Are we using replication? Failure handling. So what's going on if one of the server dies and stuff like that. So we need to provide all that information and also the upgrades, right? And this is where the MariaDB operator jumps in. So we will see what the MariaDB operator adds to Kubernetes. So first, what's the MariaDB operator? So the MariaDB operator, it's an open source Kubernetes operator to run and operate MariaDB server in a cloud native way, so in Kubernetes. So it will extend the Kubernetes API with MariaDB specific resources such as MariaDB, database, user, grant, connections, SQL job, backup and restore, physical backups, point-in-time recovery, max scale MariaDB. So all that, it's part of the MariaDB operator, and it will the MariaDB operator will give us these resources. So if we take a look on again on a schema illustration about the MariaDB operator and the Kubernetes, we can see that there is the users, there we have the Kubernetes API, and then before the stateful set and all the resources, we have the MariaDB operator that will watch the resources and continuously reconcile to the desired state, right? So a small reminder here, day one, what we call day one, it's the deployment and the initial setup phase, like the provisioning, configuration, migration, and the schema creation. Day two, here we're going to refer to the post-deployment operation. So what we do when everything is set up, you have tested it, okay, it runs, what next? So next, we need to monitor what's going on. We need to create alerting if there is an issue. We need to do some maintenances like backup, upgrades, or scale. All that information, it's for the day two, right? This is a small operator pattern on a single slide. So the operator will continuously will compare the desired state with the actual state and what we have defined, and try to converge them if they don't match. So for example, we have database defined in a database YAML file, and we will see what are the databases that are created on the system, on the database, and we see, oh, these schema are missing, so we're going to create, or there are too much, let's remove, and so on, right? So now that we know and we have understood how a bit the role of the operator, MariaDB operator in Kubernetes, let's see how we can install it. So here I'm install it with Helm. So we will first add the repo of the MariaDB operator. So we do Helm repo add MariaDB operator, and we provide the URL. And then we need to install the MariaDB operator, the custom resource definitions, and we provide them here. And after that, we install the operator, right? All this is also available not only via Helm, but on the Operator Hub, OLM, or even static manifests. Installing the custom resource definition before applying any MariaDB database user and grant resources, because if not, it won't work. And something also very, very important, it's that you need, before rolling out your proof of concept, your demo, or even your production, you need to verify several steps, like the Kubernetes version that are supported by our operator release we are using. See also if the MariaDB images are compatible, if the storage is sufficient and working as we expect, and to see if we have a CSI snapshot supported, if you want to do snapshot-based backups. And you also need to check if, oh, what do you need? If you need a community operator, or if you need something different like the MariaDB enterprise operator. Something also important is that I will recommend to pin the operator version in your GitOps operation. So don't use latest, for example, because if you're latest, you may have some changes that breaks what you have. You may have or you break a third-party tool, or you also you will miss the Git history, because it will be latest from the beginning to the end, and you won't see who changed what when. So if you put the version, if you pin the version you are expecting, every time there is an upgrade, you will get that in your Git history, right? So this is pinning will avoid to have unpredictable updates. So when you are not expecting an upgrade, to avoid breaking change, and to avoid this loss of a Git history. So now that we know this, let's see how it looks like to have the first MariaDB server instance configured in a YAML file for the operator. As we can see here, the kind is MariaDB, it has a name called MariaDB, and we provide here a name, a password, we ask for storage, and we provide also some resources for this pod, MariaDB pod, that we will deploy. So what gets created? After applying a MariaDB resource, we can expect this Kubernetes object to be present, right? So we will have the MariaDBs, the stateful set, the pods, PVC, and service. You can have information about all these and see what they do. So you can teach your team how to inspect both the custom resources and the generated Kubernetes objects. Now, what you can also do, right, it's to see the databases as code. So we will create databases and other objects, so these custom objects as code and not using SQL statement on the database. So we will be able to deploy also all these objects as code. So here, for example, this is a database definition. So, and it will become a Kubernetes resource. So here we give the kind is database. It needs to have the MariaDB, and then you see the character and the collation that is used. Same for user. User will become a Kubernetes resource. So we will define the kind users, and we say, okay, it's MariaDB. This is the user password and its login and password from where it connects. And you have also extra attributes like, for example, max user connection 50. Something very important is to not store in Git the password, plain password. Use something external like a vault secret, or if it's impossible for you, I would recommend to at least encrypt with something like YAML or some stuff like that. So we saw the MariaDB, we saw the database, we saw the user, and we have also the grant, so the privileges. It became also an object, and this is how it looks like, right? And finally, the connection we use, we also need to create a connection that will be used by the application to connect to our MariaDB instance. I also talk about SQL job, remember? So it will allow you to run some SQL statement in Kubernetes. So for example, you need to bootstrap a schema, or you have just small stuff to do, like, I don't know, add some instruments in performance schema and stuff like that, or have demo data, but or just a script that you want to run once. But I would not use that for everything because I will keep the complex migration using a migration tool made it on purpose instead of SQL job, right? So another resource that we have created with our operator is the backup. So backup, of course, you need to schedule them, and you need to also configure for how long you're going to retain them. And for example, here you can see we do a daily backup. This is his name, and we can see in the schedule that we do a backup every day at 2 a.m. We do a backup and we keep it for 14 days, right? When we have done the backup, something that a lot of people always skip or forget, it's to also have this restore resource and to create one to restore the backup and test if it restored correctly. Something important is that you can also restore in a different namespace or cluster. And also when you do the record, you need to see how long it will take to come back, and if you have check also the data. But RTO, RPO, I will come that later. So this is, for example, a backup and restore workflow schema that we can see here, how it works. So we have this instance, we do the backup, we do the restore, and we can also restore on a different namespace. Something also cool with this backup and restore is that you can bootstrap a new instance from a backup. So this is also something very nice. So here you can see the kind, it's a MariaDB one, and you can use your backup ref to recreate this server from the backup you have. Something extra that is also very important to deal with is the HA options, right? So MariaDB and Kubernetes have different HA patterns, so different. You will be able to deploy different high availability architecture, and depending of what you need, of course. So a single instance with a proper backup and restore discipline can be seen as high availability, but in this case, the time to come back, so the RPO, the objective, the RTO will be way too long, right? Because you will need to restore and run the backup and the bunny time recovery. But it depends what you have. If you have something, you say, oh, this data can be, I cannot lose it, but it can be down for 2 hours or a full day. That's not a big issue. Maybe this is enough as HA. Now you have also replication topology with asynchronous and multiple replicas, or you have the MariaDB Galera cluster topology. And of course, part of this HA tooling, we also have MaxScale that can route and do the proxying for everything. So HA is not just a checkbox that you have on your system. It you need to define which failure you want to survive and how long. So you need to define the RTO return time objective and the RPO, right, return point objective, to see, oh, how long will it take for my service to come back? So how long can my service stay down? And how much data am I allowed to lose? Can be zero, or can you say, oh, we can lose 1 day of data? It's not a big issue. We're just collecting, I don't know what, right? So, for example, if you want to create here a replication shape, we can see here that the kind is MariaDB. We give a name MariaDB REPL, and here we can see that we have 3 replicas and replication. It's enabled, and then we will have it will deploy 3 machines with or 3 pods, 3 instances of MariaDB that will replicate. So now that I told you we also have max scale, so we can have max scale in this picture, but max scale will take care of routing, read-write splitting. It knows the topology, so who is the primary of what, or who is the secondary of what, and it provides a stable access layer in front of MariaDB. So you have the application, the service, max scale, and the MariaDB pod. Of course, you need to put the connection behavior in the platform, not at every application, right? So this is how it looks like, the HA pattern with the max scale. As you can see, we have the application, the service, max scale there before having the MariaDB backend. MariaDB backend that can be a synchronous replication like it is now, or it can be a MariaDB cluster if you prefer. So now that we have done all this, it's time to go on the day 2, something maybe more interesting for the DBA and the operator. It's about in production what we can do when everything has been deployed and it is running. So on the observability point of view, we have 3 main layers that we need to monitor and to take care of. And this layer is the Kubernetes layer. So we need to monitor pods, the volumes, so the storage, events, how its statefulness is going. Then on the level of the operator, we also need to check the custom resources that we have created. Are they there? What their status? And see if during the reconciliation steps there are some errors. And finally, this is maybe sometime you think out of scope of the Kubernetes, but it's the MariaDB itself. You need to see, oh, do I have too many connections on the MariaDB? Or is my buffer pool downsized or too large? Or how is it going with replication? All that kind of stuff you need to check. Do I have slow query? Are my backups running? So all that information is very important to observe and monitor, right? The operator supports also the Prometheus operator integration and using the service monitor resource. So you need to alert, of course, on the failed backup and the missing restore test, for example. So every time you do a restore, if it fails, you need to alert not only of, oh, CPU is high or memory is low, right? So this is very, very important to know. Yeah. So now we will also discuss about some storage, and you should know that we have the PV, so the persistent volume for when we use the database, and the persistent volume claim, so PV and PVC. This is just the request for the storage, right? So for the storage, you need to use the storage class intentionally. You need to understand where are you binding your PV to the real storage and see to be sure that you are connected to it and how you are connected to it. And also check the latency, the IOPS and the fsync behavior, especially when you're on the cloud. IOPS and even more fsync can be problematic. So take a look at that. Try to get that information in advance. Then, if you're using snapshot, please validate that. Put the PVC size to something realistic. Don't ask for 2 terabytes on a system, on a Kubernetes system, where you only have a 500 megabytes, for example. And you can test the node drain and the risk scheduling also. So something very important it's to never benchmark only on an empty cluster. So when you have deploy, add data, add some workload to see to be sure your data is not empty, and then you can start benchmarking. Otherwise, your number will be completely wrong and fake. Other stuff, you need to, for the MariaDB pods, you need to set the memory request and the limits yourself to say, okay, I cannot go above that. So you need to step that and not let it choose whatever it wants. But for the CPU, then you can avoid this limit. Let the user as much CPU you need, unless you really know why you want to limit CPU. When you work with the memory, don't forget that buffer pool, connection, temp table, all that will use a lot of memory, and then you need to be prepare everything or your system for it. Then tune probes, startup time, and keep configuration in reviewed config maps and custom resource fields, right? So this is very important. So keeping this configuration in reviewed config maps and custom resource field means that your application settings are safely stored as code artifacts that go through strict human or automated reviews before they're applied on your system, right? So this very information to keep that in review in Git or in whatever you want. And this is a standard practice most of the time in Kubernetes environment to prevent all this unauthorized change and also to track the history and to ensure the stability, right? So this is very, very important to have. Yeah, OM killer, OM killed. It's a database outage with the Kubernetes label. This is also very important that yeah, you don't OM kill happen when you go above the memory that you had, and so you try to allocate more memory, and then the system needs to recover memory, and it will kill the application that consumes too much. About the secret, I already told never commit password, use a kind of secret integration application, separate the app users and the admin users. Like always in every database, you should do that, but even more here. Of course, use least privilege grant, enable encryption where it is required, and I would say try to use that everywhere. Restrict the network access with the network policy. So this is also cool because sometimes people doesn't do that. You need to, if you expect some interaction or some connection from one host or one subnet to your database, just allow this. Don't allow it from somewhere else, because even if once people might try to get access, even if they are not allowed, but they will try, and they might have access. And every time they try, MariaDB also needs to check at that, to reply to this. So and spend time doing that instead of doing something else. So I would try to just, if you don't need to connect, just block it at the network level, right? Something very important, it's also check where your image are coming from and the upgrades, right? Yeah, also make user and grant review a part of the application pull request, right? To see, okay, I need to, this is my application, I want this user, I want that it has access because it needs to read data. And so send that. And if we say, for example, oh, you need access to read, and I see you had, I don't know, update, insert, delete, access. Why? Or you ask for this table and you have access to this other database. Why? What's the point? So all that should be reviewed. Yeah, GitOp's tips. So this is the repository uh, shape I would recommend. So you have your cluster, your prod, and then you can see here you have the MariaDB operator, the databases, the user, the grants, the backups, all defined themselves in their YAML file inside of different folders that make it clearer to understand, right? So before upgrading, and here before upgrading your operator, please, it's like for database, I would say, read first the release note, upgrade progressively, meaning that if you want to upgrade several versions further, maybe you need to do intermediately. Uh, Confirm to see that the custom resource definition if changed or not. Check before doing that, always do a latest backup and see and test it to restore if it works fine. Test in staging with the production like data, and this is easy because you can, like I showed you earlier, you can let's say bootstrap from a backup. So you will have production data and monitor the reconciliation after the upgrade, right? So you need to treat this operator upgrades like database platform upgrades, right? It's not just a Helm chart upgrade. So if something goes wrong, it might, even if we have made a lot of tests and stuff. So this is a troubleshooting checklist that I provide you. So if you have something wrong, use this function or this statement to get the information you need to be able to troubleshoot. So get the MariaDB database, user, grants, backup, describe the MariaDB, you try to get the events, get the logs, get all that information. And this is very, very, very interesting, right? To find what's going on, what's going wrong, right? And what could go wrong. In fact, this is the common causes of issues. Uh, One, the custom resource definition are missing or have a wrong version, or the secret name and the password are have a mismatch. So that could be an issue. The storage class problem. So you're asking for something that you won't get, or you have not enough memory. You consume all the memory, and all your ports together will go bypass the available memory, stuff like that. Or for example, you have a very slow startup for any reason, and the probe will test before it's already finished, and that could be an issue. And finally, network. Network is always a problem. Everything it's a DNS issue, right? So you need to verify that. So when you have done and you say, okay, let's go to production with our system, what we need to do? We need to be sure that we have the supported Kubernetes operator and MariaDB version all together if they fit. Then to see if we have which storage class we have tested, and if we have tested under failure and under AV system, if we have the schedule of our backup, and if we try to restore them, and if they are monitored, we need to check all that. And if we can answer yes to everything, or okay for everything, then it means that we are ready. So we need to see the sizing reviewed. So everything, that all the resource together, if they consume everything, is not way too much. The security model, how they connect, where they connect, who's connecting, we need to review that. Do we have our observability dashboard ready to monitor and alert on all the things we need? So we need to verify that. did we try an upgrade? Usually people don't do that. They deploy, they test, and the first time that we really test the upgrade, it's on production when there is a new upgrade. So I would also highly recommend to do the upgrade before going in production. So you have tested and validated your upgrade procedure. And finally, find who own the disaster recovery process, because this is something you need to test, and I hope not to have to do it in production, but it could happen. It's good to know it. So now, just in some comments, I will show you a small demo flow on how to do that. So first, you install the operator. With Helm, install MariaDB Operator, CRDS, then the MariaDB Operator. Then you create your secret, so you apply the MariaDB YAML. Then you declare your DB access. So here we create databases, user, grants, connection. And finally, you can also add the backup and the restore. So this is how we apply it, or we can apply this MariaDB environment using the operator. So some key takeaways. So stateful set, it's very important and gives MariaDB a stable entity and the storage, but not the full operation. So this is why you need the MariaDB operator that will make the MariaDB operation declarative. The custom resource definitions, such as what we saw, MariaDB database, user, grants, connection, backup, and restore, move the platform work into a GitOps workflow. And finally, the production success will depend on the storage, on the backup, restore the test, and the observability and upgrade discipline. So if you have tested everything, if you know what to do, if you know who owns it, all the stuff, your experience with MariaDB Operator in Kubernetes should be a success story. So time for question. And before I reply your question, check the resources that I used or that we refer in this presentation. So on GitHub, the documents, the foundation article. So thank you very much to join this big family of MariaDB users and MariaDB sponsors. Thank you.